Alright, hi everybody. Today we're going to be working on the Instagram lab, which is lab 3. What we're going to try and do today is create a bunch of Instagram-esque filters that make our image look different. It's going to introduce us to a couple new concepts which can be difficult to pick up, but they're not that hard, I don't think. What we're trying to do is process an entire image, pixel by pixel. So I think it's pretty easy to think of this as like a graph. Each image is a graph, and we're going to go through each point on the graph, and we're going to do something with it. So the way we want to do that is, I think it makes sense to introduce an x value and a y value, and create a for loop that goes through every possible x value, and then inside that, every corresponding possible y value. So we get this thing that's called a nested for loop that runs for the entirety of the image. So that is from x equals 0 to x equals the width of the image, which is called by newImage.width. And then for y from 0 to newImage.height. So we've got our for loops, and that means, and now we are working with every individual x and y value on this chart we've got. So we're going to introduce a variable pixel, which is each individual value on the graph, each x and y ordered pair. So we're going to set this pixel equal to originalImage.getRGB of x and y, which takes the pixel at x and y of our original image. And then we can call the RGB values, that's the red, green, and blue values of that pixel. And we want to create a negative of this image. So what we do is take 255 minus the value of pixel.r and pixel.g and pixel.b. This takes each individual color value and sets it to the inverse, the negative version of it. Pixel.r, pixel.g, and pixel.b all range from 0 to 255, which is the maximum value of each of those components. So then the next thing we want to do is set the RGB at that x and y location of the new image to this pixel we've created, with the values of 255 minus pixel.r and 255 minus pixel.g and 255 minus pixel.b. And then we want to return this new image we're creating. Alright, I'm going to browse. I googled beautiful images, and this is what came up. And it worked. Fantastic. Alright, the second part we're going to work on is filter alignify, which is a little different. We're not going to be working with RG and B anymore. We're going to be working with HSL, which stands for hue, saturation, and light. First thing I want to do is introduce our new function down at the bottom, which is going to be called filter alignify. We're going to take an image, and we're going to try and make the entire image blue and orange. We're going to alignify it, so to speak. So I've created filter alignify. I named it the wrong thing down there. I don't want it to be called filter x-ray, or I don't want it to be called x-ray, but I'll change that later. So we're going to introduce this new function, filter alignify, and we're going to do kind of the same thing we did above. We're going to do the nested for loops with x and y, and we're going to create a pixel variable. But then we're going to take the pixel's HSL values. That's hue, saturation, and light. Specifically hue. We're going to take the pixel's hue value, and we're going to make it so that the hues can only be orange or blue. So first thing I want to do is create the pixel value, which is original image dot get HSL at our x and y, our variable x and y point. And then I want to pick a cutoff. I want to pick a cutoff for the hue of the pixel, where any hue that's greater than that becomes orange, and any hue that's less than that becomes blue. I've already decided that that the H value of 175 looks pretty good. It's arbitrary. It was kind of up to you to pick an H value. This is one that I liked. I thought it looked good on the picture, and I'm going to set it equal. If it's greater than that, I'm going to set it equal to 246, which I believe is blue. And if it's less than that, less than or equal to that, excuse me, I'm going to set it equal to orange. I don't remember what the orange value I picked was. Pixel.h is going to be equal to 33. Alright. That's all you really need to do, and then you need to, that's not all you need to do, I lied. You need to set new image dot get it, you need to set the HSL value of the pixel in the new image at x and y to the pixel we have right there. I'm going to close my for loops, and then I'm going to return new image, just like the last one. Save, and let's open it up. I don't really like that orange value. I'm going to fidget with it a little bit. And I'm going to change the name to Align-ify because I forgot to do that. Alright, I'm going to save and let's try it again. This is a really orange and blue image already. Alright, I'm going to try and make it a little more orange. See if we can get a good effect. Alright, it looks pretty good. I can accept it. It looks Align-ified. Alright, the third part we're going to do is the Align-ify More filter, where we're going to take the saturation value and we're really going to ramp it up. This was not too difficult a task because we can kind of borrow a lot of the components of this function from the last one we have, from the last one we did, from filter Align-ify. So what I'm going to do is copy filter Align-ify and rename it filter Align-ify More, and then make changes from there. Alright, so if our pixel.s is less than 0.5, I want to add 0.5 to it. But what happens if it's greater than 0.5? I can't add 0.5 to it because I'll go over the the maximum value for saturation, which is 1. So I'm going to say that if pixel.s is greater than 5, or greater than 0.5, we're just going to set it equal to 1. And if it's not greater than 0.5, we're going to add 0.5 to it. And this is going to make the image a lot stronger, a lot more saturated. I'm going to open this up. We're going to see that we have a lot more compelling image. Oh, I opened it in the wrong thing. Alright, we're going to compare it to the Align-A-Fi filter, which is a less strong. Ooh, look at that. It's an incredibly powerful blue and orange. Alright, this has been Lab 3. I think it was Lab 3. Yeah, Lab 3.